In this section, we're going to look at how we evaluate logarithms with different bases, as well as reviewing our three basic rules about condensing and expanding logarithms. So the first thing is going to be the change of base formula, and the change of base formula allows us to evaluate a non-standard base log. By non-standard base, we mean not base 10 or base e. So something that would be log base 4 of 17, that is something that is not a common base. There is no log base 4 button on your calculator. The button that says just log is log base 10, and then ln is log base e. So I need another way that I can create a common base. And the way we do that is with the change of base formula. The change of base formula says that if I have log base anything of x, I can rewrite that in terms of a common base, which would be log of x divided by the log of a, where both of these logs are base 10. So then I can use my calculator to plug directly in anything that's not a base 10. So the first one right here, log base 12 of 235, how would I solve that? Well, since there's no log base 12 button on your calculator, you would apply the change of base formula, which says I'm going to take the log of 235 and divide by the log of 12, which is going to give me 2.197. So very straightforward process. If you've got the TI-84 Plus with the new operating system, under math there is an option to have a logarithm with any base. So if you want to use that function, feel free to use it. The second thing we want to look at today are the properties of logarithms that we use to expand or condense expressions. And today we're not solving for x's or y's or z's, we're just expanding or condensing, which will lead us to be able to solve x's, y's, or z's. So the first thing is the product property. The product property says that if I have log base a of x times y, I can split this into two separate logs, log base a of x plus log base a of y. When you separate stuff in the product property, the two separate logs get added together. And if I were to go in the reverse direction, if I have two separate logs that have the same base that are being added together, I can combine and multiply their back components. The second piece is the quotient property. Log base a of x divided by y, I can expand out to log base a of x minus log base a of y. So when you've got the quotient property, when you expand logs, it turns into subtracting two separate logs. And if you have two separate logs that have, once again, common bases, or I should say the same bases, log base a, I can combine those together by dividing x and y. The last piece is the power property. Log base a of x raised to a power. I can roll the power out in front of the log and rewrite that as the power times log base a of x. Also, if I've got a quantity being multiplied out in front, I can pull that back as a power. When you expand an expression, so we're going from a very small expression to a long expression, you do the product or the quotient property first, whichever one you have, going from left to right, and then you do the power property last. However, when you condense an expression, which means you've got a long expression and you're going to make it really small, you do the power property first, and then the product and quotient properties last. And once again, we've got to be thinking about our parentheses. If we have anything in parentheses, that gets done first. So this works 90% of the time, and this is the mindset that you want to have as you go about solving. So the last piece on this page is doing some expanding of logarithmic functions, and we'll continue in the next video. But for this one, log base 10, if nothing's there, it's understood to be 10. So log base 10 of 3 times x squared times y, I can see there's two properties there, a product property and a power property. So since I want to expand, I'm going to do the product property first, which is log of 3 plus log of x squared plus log of y. I take every single piece here that is being multiplied and make it a separate log being added. And then I can see in this middle term I've got the power property, which then I can roll that power out in front of that one log. So log of 3 plus 2 log of x plus log of y is my fully expanded form of log of 3x squared y.